So I just wanted to do a couple examples of dividing two complex numbers. I think the adding and subtracting and multiplying has been pretty straightforward for you, but people were asking for more examples of dividing. And I'll actually show you two different ways. I'll show you the trick that I did in class, and I'll show you a different way that some people might find more intuitive. They're both totally valid ways to do it. So here's number one, the way that we done in class. Let's just take two random complex numbers and we're going to divide them. And our goal is to get it into standard form, to get it into a plus bi. So what I have shown you the last couple classes is that multiplying by a conjugate will turn a number into a real number. And so if I look at the denominator, I can change the imaginary part around and keep the real part the same. And then I have a conjugate. And multiplying by the conjugate on the bottom will give me a real number. So we're just going to do a lot of multiplying. 4 little multiplication problems on the top, 4 little multiplication problems on the bottom. So we got 4 times 11, 4 times negative 2i, negative 7i times 11, negative 7i times negative 2i. So please double check that you get why all 4 of those pieces make sense for the numerator. And on the bottom, 11 times 11, 11 times negative 2i, positive 2i times 11, negative 2i times positive 2i. Now the big thing that we do in this unit is we remember that I squared is equal to negative 1. Also notice that negative 22i and positive 22i cancel out. So now I can combine my like terms. On the top, I have a 44 and a negative 14. I know it says plus 14i squared, but I squared is negative 1, so you can read that as minus 14. So that's where I get 30. The imaginary numbers are both negative, so it gets bigger negative. On the bottom, I have 121 minus 4i squared. I know it says minus 4, but the I squared makes it plus 4. So 121 plus 4 is 125. And then I write it in a plus bi form. I guess we could simplify those because those are all divisible by 5. So I guess it's 6 25ths. How many 5s go into 85? 17 25ths I. That's your answer. That's in standard form. So I want to show you a second way we can do this same problem without knowing about the conjugate. So let's say that we wanted to divide two complex numbers, and we want the answer to be in standard form. So I'm going to make it equal to standard form. How do you get rid of a fraction? Well, the way you get rid of a fraction is you multiply. So I'm going to multiply both sides by 11 plus 2i. So that cancels it out from the left side, leaving me with just 4 minus 7i. And on the right side, I have to do my distribution game. So I have 11 times a plus 2i times a plus 11 times bi plus 2i times bi. So 2bi squared. So look at all 4 of those pieces. Make sure it makes sense where I got those pieces. What I'm going to do is the same thing I did before. I squared is negative 1. And I'm going to group my numbers in a very specific way. 4 minus 7i equals 11a minus 2b. And it became minus because of 2bi squared. And then the other ones I have are 2a plus 11b I. Notice what I did. Both of these terms here have a common I, and so I can factor that I out. Now, what you have here is actually a system of linear equations. You have the real part needs to equal 4, and the imaginary part needs to equal -7. And so you can set up two different equations to solve. I'll do it over here. We have 4 equals 11a minus 2b. And our other equation that we have is -7 equals 2a plus 11b. So you can solve this with elimination, or you can solve this with substitution. Either way is just fine. Um, yeah, why don't we just multiply this equation here? We'll multiply this equation by 11, and we'll multiply this equation by 2. I'm going to do elimination. I'm going to write them both down here. So here we have 44 equals 121a minus 22b. And then the other one is -14 equals 4a plus 22b. And if you add those two equations together, see how I multiplied by 2 and I multiplied by 11? That way the b values are both going to be 22. It's kind of like when we did common denominators. We took one denominator and multiplied over here. I'm doing the same thing, but for elimination. 44 plus -14, 121 plus 4, and the b's cancel out. And guess what we get? The exact same answer as before. 30 over 125 is equal to a. Then you can just substitute that back in and solve for b using either one of the equations that you want to. And you'll end up with the exact same value of -17 over 25. Okay? So I just wanted to show you that, I like using the conjugate because I know that it works. But I also know that it feels like kind of a trick that you have to pull out of nowhere, where what you can do instead is just say, well, I want my answer to be a plus bi, and so I'm going to multiply and figure out what a and b both have to be using my system of equation skills. All right, thanks for watching. Let me know if you got any questions.